Welcome to today's lecture on sample handling in infrared spectroscopy. Whether you're a student, researcher, or just curious about infrared spectroscopy, this session will equip you with essential techniques for preparing and analyzing samples effectively. So, let's dive in. Infrared spectroscopy is a powerful analytical technique used to identify and study chemicals based on their molecular vibrations. However, the accuracy of IR spectra heavily depends on how the sample is prepared and handled. In this lecture, we'll cover the key techniques for handling solids, liquids, and gases to help you get the best results. By the end of this session, you'll be equipped to optimize your sample preparation process. Let's start with solid samples. There are several methods you can use, depending on your sample type and requirements. KBR pellet method. This involves grinding the sample with potassium bromide and pressing it into a pellet. It produces high-quality spectra, but can be time-consuming. Mull technique. Here, the sample is mixed with a mulling agent to form a paste, which is then placed between IR transparent windows. Diffuse reflectance. Ideal for powdered samples, this method uses a reflectance accessory. ATR technique. Simply place the solid sample on the ATR crystal for surface spectrum analysis. Quick and convenient. Additional tip is to ensure proper sample grinding and uniform mixing to avoid scattering effects in the spectrum. Now, let's move on to liquid samples. These are commonly analyzed using three approaches. Neat samples. A drop of pure liquid is placed between two IR transparent plates, perfect for non-volatile liquids. Solution samples. Dissolve the sample in an IR transparent solvent like carbon tetrachloride or chloroform and use a fixed path length liquid cell. ATR technique. Just like with solids, ATR allows direct analysis of liquids without specialized cells. Pro tip is here. For volatile samples, minimize evaporation by sealing the liquid cell properly. Handling gas samples requires specific precautions due to their volatility. Common techniques include gas cells. These long path length cells enhance absorption signals and are ideal for volatile compounds. Sealed cells, used for reactive or unstable gases. These cells prevent interaction with atmospheric components. Make sure gas cells are free from leaks and properly flushed with inert gases if needed. ATR technique. Just like with solids, ATR allows direct analysis of liquids without specialized cells. Pro tip is here. For volatile samples, minimize evaporation by sealing the liquid cell properly. Regardless of the sample state, precautions are necessary to avoid contamination and errors. Avoid moisture contamination. Many IR windows, like NaCl and KBR, are hygroscopic. Proper sample preparation. Ensure fine grinding for solids and eliminate bubbles in liquids and gases. Use compatible solvents and materials. Avoid interference with IR spectra. Thorough cleaning between measurements. Prevent cross-contamination. Always handle samples with clean tools and gloves to maintain purity. Let's explore modern techniques that simplify IR spectroscopy. ATR, attenuated total reflectance, requires minimal preparation and works for solids, liquids, and pastes. Microspectroscopy enables analysis of microscopic samples, commonly used in forensic and biological studies. F-tier imaging, a cutting-edge approach that allows spatial mapping of chemical compositions within a sample, providing high-resolution insights. Did you know? F-tier imaging is widely used in pharmaceuticals for quality control. In summary, proper sample handling in IR spectroscopy is essential for achieving accurate and reliable results. From traditional methods to modern techniques like ATR, you now have a toolkit for analyzing different sample types with confidence. Consistency in preparation leads to consistency in results. Practice and refine your methods. Host, thank you for watching.